Hello everyone. So in this video we'll discuss about the band reject filter. So it is also called a band stop or band elimination filter. So in this it has two pass band and one stop band. So in the stop band the frequencies are rejected. So in the pass band frequencies are passed. So it has been classified into two types: a wide band reject filter and the narrow band reject filter. So the wide band reject filter is composed of can be designed using a low pass filter, high pass filter and a summing amplifier. So to realize a band reject response, so the lower cutoff frequency FL of the high pass filter should be larger than the higher cutoff frequency FH of the low pass filter. Okay, so there are two things that we can realize the wideband reject filter. The lower cutoff frequency FL of the high pass filter should be greater than the higher cutoff frequency FH of the low pass filter, and also the pass band gain of both the filter, that is high pass filter and the low pass filter, should be equal. So this is the circuit of a band reject wide band reject filter, that is it rejects the wide frequencies, wide band frequencies, that is it can reject a large band of frequencies. So that is why it is called it is made up of a low pass filter, high pass filter and a summing amplifier. Okay, so here it is FH, FL, FH and FC. Okay, so this is pass band, stop band, where here the frequencies are rejected, and this is the pass band. Okay, so narrow band reject filter. So here it is also called notch. So here this will be wider. In the narrow band pass filter, the frequency rejection will be very little, they're very thin. Okay, so that is, it is also called notch filter. It is commonly useful for rejection of a single frequency. Suppose we need to we suppose we don't have some frequency like 500 hertz or 530 hertz. So that time we can use a narrow band reject filter. So it is useful. So it is commonly used to reject a single frequency. So the most common type of notch filter is used twin T network, so which is composed of a passive components, or a passive filter composed of two T-shaped network. So it is a passive filter composed of two T-shaped network. So the one T network is made up of two resistors and one capacitor, two resistors and one capacitor, and another T network uses two capacitors and one resistor. Okay, so this is called T network. So the notch out frequency, or the frequency at which maximum attenuation occurs, that is the frequency of rejection, this is the frequency which can be rejected, is given by 1 divided by 2 pi RC. So this is a twin T notch filter, okay, which composed of two T networks. One is composed of one resistors, two resistors and one capacitor, and another T network composed of one resistor and two capacitors, and the frequency of rejection or maximum attenuation occurs is given by Fn is equal to 1 divided by 2 pi RC. So the Q of the network can be increased significantly if it is used with a voltage follower as shown in the figure. So we can use the Q, that is quality factor of a filter, by using a voltage follower circuit like this. Okay, so this notch filter or the narrow rejection filter is mostly used in communication, biomedical instrumentation for eliminating undesired frequency, that is frequency which is not useful. So for such application we use notch filter. To design a notch filter for a specific notch out frequency Fn, for a specific elimination of frequency, the value of C should be less than or equal to 1 mu farad, and then we can calculate the value of R. So this is the frequency response of active notch filter. So the band of frequencies you can observe. So this is that is which is very narrow. So Fn is the notch frequency, which is denoted by Fn. So this is the frequency response curve of the band reject filter. Okay, so the band reject filter, so narrow band reject filter is also called notch, which is used to eliminate a particular frequency. Okay, thank you.